Welcome to Embedded. I am Alicia White, alongside Christopher White. Our guest this week is Professor Alan Blackwell, and we're going to talk about AI and programming languages, but probably not in the way you think we're going to talk about them.
Hi, Alan. Welcome.
Hi, it's nice to be with you.
Could you tell us about yourself as if we met at the user experience conference that Marianne Petra just keynoted?
Yeah, so I've come into this field as an engineer, and a lot of the jobs that I've done over my career have involved designing new programming languages. So I guess the first one of those was nearly 40 years ago. The systems that I was deploying, which in my early career were generally industrial automation or laboratory automation systems, I always found it super interesting to talk to the people who were using the systems. And then quite often I thought I could really help them with their job if rather than just giving them a static user interface, I gave them some kind of simple scripting or configuration or programming language. So yeah, long ago I used to talk to people about what's your job and how can I make it easier for you by helping you to instruct a computer to do pieces of it for you. So yeah, that's been a long-term interest, but I'm kind of intellectually curious. I did a degree in philosophy and comparative religion, and then I heard about this thing called artificial intelligence, which is a way of combining an interest in people, an interest in philosophy, and an interest in engineering. So that was a little while ago, and some people are surprised that I started my research career in artificial intelligence in 1985, which is before many of today's leading experts were even born. So basically, I got into artificial intelligence because of an interest in programming languages. Over the years, I worked for corporate research labs and big companies, and actually deploying new AI tools. And often they included novel programming languages. So I went from programming languages into AI, and then out of AI, I became a programming language designer again.
Okay.
And a professor.
Yeah, that was a byproduct, to be honest. I really didn't think I wanted to do that. And my dad, who was a proper engineer, was really disappointed. Like, I can't believe you're going back to school again. Like, you're a good engineer. But things are pretty sweet here in Cambridge because the university has got a very liberal attitude to intellectual property, and it's super easy to start companies here and do consulting for big companies like Intel or Microsoft or Google or whatever. So after I actually ended up late in my life doing a PhD in applied psychology in order to understand the cognitive ergonomics of programming language design, I thought I would go back to a commercial lab again to design more programming languages, but I discovered that by becoming a professor, I could work for far more companies and design far more languages. So I've really been enjoying doing that for the past 20 years. All
right. We want to do a lightning round where we ask you short questions, and if we're behaving ourselves, we won't ask for a lot more detail. Weirdly, I ended up with a lot of these for you, so we'll try to go kind of fast, but don't feel any pressure.
Okay.
Would you rather have dinner with Bootsy Collins, Geddy Lee, or Carol Kay?
Oh, tough, but definitely Bootsy Collins because I'm a bass player.
Sometimes we ask when the singularity will occur, but for you, I think, what year do you think we'll stop using a floppy diskette to indicate saving things?
Well, so many words in our language, we can't even remember where we got that word from. So I think a floppy disk has already become just a kind of emoji. Like, I would be very hesitant to ever put an aubergine in my text message because I sort of know that what it means is not what I think it means. So I think the same with a floppy disk. People don't really care what it looks like. They just need to know that it's a symbol and it means something.
Would you rather spend an hour with a well-trained parrot or a stochastic parrot?
I don't like parrots very much. Yeah. Stochastic parrots are kind of fun. But they don't bite you. They don't poo all over the place. So, yeah, probably.
Not yet, anyway.
Yeah, heaven forbid. Yeah, no, I'll go with the stochastic one.
Would you rather have dinner with Alan Turing or Claude Shannon?
Oh, cool. Wow, I would love that so much. Yeah.
Which one?
Yeah. So I guess the thing is that Alan Turing was a student and professor at Cambridge. I know a lot of the sort of people that he hung out with. I have a friend who played chess with him when they were kids. So although I would love to meet him, I sort of feel like I probably pretty well understand what sort of person he was. Claude Shannon, absolutely incredible. Yeah, I think I would Yep. 10 minutes with him would probably already double my knowledge of the real ground truth of information theory.
I would totally crash that dinner.
If you were teaching an adult to program, would you start with Scratch, Excel, or Python? Or something else?
Yeah, so I have done this. I used to run a class where I taught humanities professors what they could do with programming languages.
Nice.
And I liked Scratch. And the reason for that is that it's more interactive. You can use multimedia immediately, so you're not stuck just in text and number world. Yeah, so yeah, Excel definitely is good. And I use Excel a lot. I can definitely help people do useful stuff in Excel. But for example, when I designed a programming language for artists, and then I spoke to a sculptor friend and said, what would you like to do with this? And she was like, I use a computer when I have to do my accounts using Excel, but why would I ever want to use a computer for my actual job? Because that's fun.
Have you ever held a Weta?
Oh, worse than that. Yeah, I have had a Weta, and the horror of a New Zealand child is to have a Weta, which is a sort of giant cricket with big poisonous spines on its back legs. I have had a Weta inside of my rubber boot when I put my bare foot into it. That is super nasty. But yes, I have also held a Weta because in my sixth form biology class at the end of high school, we didn't dissect mice and lizards, but we did dissect Wetas.
I didn't know they were poisonous.
Actually, I might have been exaggerating a little bit. They give you a nasty scratch, and it gets quite inflamed. Maybe it's just a little bit allergic rather than poisonous. Yeah, we don't have poisonous animals in New Zealand. It's not like those Australian spiders.
Everything in Australia is poisonous.
I mean,
even the mammals are venomous.
The first time I spoke at an AI conference in Australia, I stayed with friends in Sydney, and they picked me up from the airport, and they said, just one thing, Alan, while you're staying in Sydney, do not put your finger into any holes in the ground. Yeah, I wasn't anticipating that I would do that, but now that you mention it, I will definitely...
We really mean it, though.
Exactly.
What is your favorite fictional robot?
I'm sort of interested in the really extreme ones that transcend the boundaries of what we might think it means to be human. I guess I liked Anne McCaffrey's The Ship Who Sang. What would it be like to have a spaceship as your body?
Yeah, they had lots of adventures.
And Anne Leckie wrote a book with that premise too, right?
Exactly. Yeah, Anne Leckie for sure. And in fact, I think her trilogy starts with one of those minds that has been ejected out of a ship and then is unconscious in a desert planet or something. Yeah, that was a great book. I really enjoyed that. And actually, I think it asks super interesting questions that I'm doing a lot of research at the moment. Just saying, now that we've got these things which produce language but are not really intelligent in the way that we used to think of being human, what does the body really give us? And that asks us a lot about what part of our intelligence is actually only there because of our body. I
think there's a lot of fiction that is relevant to that. I think even Bradbury kind of asked the question of, why would you make an android? Why would you make a robot look like a human? There's so little that we can
That's
do.
for us, not for an android.
that a robot bartender, I think, was one of the places it came up. Why would you only give it two arms?
Yep, absolutely. And I think that this is, of course, one of the things that I riff on a little in the book is where I claim that AI is a branch of literature, not a branch of science, because so much of AI is about just imagining what it would be like to be a human if a human was a different kind of thing. And that puts us in that tradition of all those stories going back centuries and even millennia to what would it be like to have a statue that comes to life and behaves like a person? Or what would it be like if you made something out of clay and then you put a scroll inside it and it came alive? For me, for science fiction, all of those things are science fiction. And what they're about is imagining different ways of being human.
One of the things that you didn't cover in your book, which I don't even think we've said the name of.
No, we were still in lightning round, so we had to transition out of lightning round.
Oh, okay. We kind of did.
Yeah.
So your book is, wow, this is something I really should know. Moral codes. Could you talk about your book for, 30 seconds to 2 minutes? Sorry, that question didn't come out well, but let's just go with it.
So the title of the book is Moral Codes, Designing Alternatives to AI. So The designing alternatives part, I think, is what's going to be most welcome to embedded listeners, because what the book is all about is saying the world needs less AI and better programming languages. So the whole book is really arguing for that. And I talk a little about AI, and I talk about what it can do and what it can't, just addressing this kind of public anxiety. But then I get back to the theme that I'm really interested in, is to how can you make the world a better place if you have got better programming languages? And it turns out that that can deliver a lot of the things that AI people think are their biggest problems. So a shorthand way of saying this to people who know a little bit about computers, but also have some training in philosophy, would be to say, just imagine that you wanted to tell a computer what to do in a way that you could be confident that it would do the thing that you've asked it to, and also that if it behaved differently, you could say, why did you behave the way you did? So those are the things that have got technical terminology in the philosophy of AI. The first one they call the alignment problem. The second one they call the explainability problem. But then I say to the philosophers, just imagine if we did have a way of telling a computer exactly what we wanted to do and then ask it why it did those things, if we designed a special language that would allow us to achieve those things, what kind of language would that be? And the philosophers go, oh, wow, yes, that's really profound. Yeah, definitely. Like, I can see where you're coming from here. That's a really interesting philosophical question. And they say, well, guess what? We have a language like that. It's called programming language.
Yeah, sort of.
Like, we have been designing programming languages for 50, 60, 70 years. And for that long, there have been computer scientists who have been improving them to make sure that the computer does a better job of doing what you wanted it to do, and also so that you have a better job of being able to read it and understand why it does those things. That's like the fundamentals of programming language research, but that is a different branch of computer science to AI.
Just to level set here, how would you define AI? Because it's gotten a little muddled.
Yeah.
At least in recent decades.
Something that's coming in 10 years.
That's nuclear fusion.
Yeah, definitely AI has been coming in 10 years as long as I've been in the field. So I think this is a book that is written for the general public, because I think it's important that people who are not computer scientists have a better idea of what sort of things you can do with AI and what sort of things would be better to do with programming languages. But when talking to the general public, of course, they don't know the difference between what those two things are. They don't know which kind of algorithms are compilers and which kind of algorithms are large language models. But what they do know is that software is changing the world a lot. So to some extent, everything that's happening today, they think of as being AI.
Right.
And that's definitely true of the recently completed European AI Act. Because when you look at the way that software systems are described, it's not really about AI at all. It's just about, like, here's what software ought to do. And I've even spoken to people who work in Brussels as members of the policy teams that were contributing to drafting that legislation. And I said, would it be right to say that you could just replace the word AI with the word software throughout this legislation, and it would really make no practical difference? And what I was told by the Brussels policy researcher is, yeah, absolutely. That is definitely what we're wanting to achieve here. We're wanting to provide a better way of governing software, and we just use the word AI because there's so much kind of hype about that, and that tells people kind of that we're working at the leading edge. And that has been...
No!
Yeah. Well...
Don't worry, they're lawmakers. They do this sort of thing for a living.
So I can tell you, from my perspective... I said I've been working in AI since 1985. The algorithms that I was using back then, like, nobody calls those things AI today, like A-star search or functional programming. Those were the sort of day-to-day tools. Nowadays, those are just useful algorithms, useful languages. We don't call them AI anymore. And in fact, I think that's been a pattern throughout my career, is that stuff that is AI 1 year, 5 years later, is just working software. In fact, there used to be an old joke from my master's supervisor who had spent years at the MIT AI lab. He used to say, if it works, it isn't AI.
Yes, exactly. Yes.
Well, when we were coming up, expert systems were the only real AI that was out, quote, real AI that was out there. And they were just glorified databases and lexical parser kind of things, right?
Hey, I did my research.
I know you did your
that.
research, and it was very cool, and nobody talks about it anymore.
Yeah, I've built some cool expert systems.
Yeah,
absolutely. And of course, in 10 years' time, we'll look back at what ChatGPT does, and we'll say, oh yeah, that's just a there were the phrase LLM is going to be right in there. Oh, that's just a transformer, or we got better things than transformers, or we'll understand more generally why cross-modal AI seems to be a thing of interest. But a lot of what I'm interested in here is separating the value of the algorithms, which are great. I love a cool new algorithm, and then what are you going to be able to do with that algorithm? And I would say throughout the long history of software engineering, the really super interesting things you can do with an algorithm are seldom apparent right at the start. So usually people give demos that are based on things they read in science fiction books, or maybe just what they wrote in their proposal or told their manager. But if it's a good one, over the next 5 or 10 years, you think, oh wow, actually there's something super cool you can do with this, even though I didn't know that when I first made it.
You separate the concept of AI into control systems, and social imagination.
Yeah, the reason for this is that there's two causes of confusion between what I call the two kinds of AI. Somewhere else I called one kind the objective kind of AI and the other the subjective kind of AI.
Okay.
So they get mixed together for two reasons. One is that they have both made good use of recent advances in machine learning algorithms, so especially deep neural networks, or maybe Bayesian machine learning more generally. And the other reason they get confused is that it's in the interest of some companies to not have you think too hard about the differences between them, because one kind is generally pretty useful. What is now called reinforcement learning by trendy young researchers is what, when I did my undergraduate major in it, was called control theory, or closed-loop control, or previously cybernetics. But basically, you need good learning algorithms if you want to have a system that observes the world somehow and then changes things. So, of course, that is the foundation of robotics and all industrial automation and all kinds of super useful stuff that I've got in my own house. So that's objective because it's just observing the world, making measurements, and doing things. So that's good engineering stuff. There's the other kind of AI, which is the science fiction literary stuff of what would it be like to be a different kind of human? Can we make a computer that pretends to be a human? And I consider that to be a branch of literature because it's about reimagining what we are. So companies that want to say reimagining what it is to be human is a useful thing to do quite often do that by blurring the boundaries between stuff that humans do in their own minds and with each other, and stuff that robots do when they're usefully pottering along the road, not driving over the curbs and things. So when it comes to autonomous vehicles, for example, that's a real challenge because some of the things we do in cars are human things, some of the things that cars do are mechanical control systems. So you can do some parts of autonomy very well and other parts really badly. Personally, I prefer the word cruise control because that was sort of an understood boundary of there's some decisions I want to make, there's some decisions I want my vehicle to make. And as long as we don't confuse the subjective and objective parts, I'm very happy for my cruise control to do automatic stuff that I don't want to be attending to all the time. But there's other things I really don't want my car to do for me.
And that confusion exhibits itself in our industry. We see it quite often.
Oh, yeah.
Where somebody's like, well, I have bought this new chip. It's got an NPU on it. I would like to make a model that, controls the temperature of this, to make up an example, but we've seen similar things. That controls the temperature of this thermistor or something like that. And it's like, well, we have a thing called the PID loop that can do that in like 15 lines of code. Why are you using a neural network to do that? And it's like, because that's, and I think certain companies doing autonomous vehicles, which will remain nameless, have been pushing to put the entire self-driving stack into a neural network and have it manage all the control systems, which strikes me as completely insane because you have well-established ways of controlling motors and actuators and sensors. The neural network part should be deeper, a smaller kernel that's making, quote, fusion decisions about the world and stuff like that, if at all. So I think the confusion is both it seems like it's both in the public, but it's also at the engineer level where people are like, oh, I'll just throw in a model at this problem when there's well-established, books full of
actual solutions with transparency and explainability.
Right, working control systems. Yeah.
Yeah. Part of this is about engineers, and I'll hold up my hand and say I'm guilty of this too. We loved reading science fiction when we were kids. So the three of us, we were all just geeking out about science fiction books before. Sure, engineers love reading science fiction, but partly because it describes worlds where engineers get to be the boss and rule the world. But quite often, if you've got you're working on a relatively mundane piece of engineering and you see something that looks like a thing that you read in a science fiction book, it's like, oh, this would be so cool to do this. Like, I'm actually having fun in my job. So I think that's one of the challenges that we need to face is the temptation to use inappropriate solutions when something simpler would work better. And I think, right back in my early career, it's something that the old grey-haired engineers would always say, there's a simple way of solving this problem. Why don't you do that?
Because it's not any fun.
I don't know. I feel like some of these pushed upon neural network AI solutions to simple problems is just marketing.
Oh, there's a lot of that happening because the people have chips to do it and they want to sell them. So engineers are receptive to marketing.
There's a super pernicious kind of marketing that is going on right now, and that's the use of the term artificial general intelligence.
Oh, yeah.
And I really come down hard on this in the book because the word general here is meant to imply, no limitations at all. This can do anything. AGI is basically a synonym for magic. So I claimed in the book that whenever somebody says to you AGI, what they're actually saying is magic. And when they say this problem pretty soon will be solvable because we'll have AGI, what you should hear is this problem pretty soon will be solvable because we'll have magic. I sort of thought that nobody would ever be dumb enough to just outright say, by the way, I've invented magic. The interview between British Prime Minister Rishi Sunak and Elon Musk last year, when Elon literally said, the thing about these AI technologies is that they're actually magic, so they can do anything. I'm like, oh my God. I had a little doubt about Elon's engineering credentials, but we get skeptical when people are making direct appeals to magic. And I try to explain in the book for a general audience that there's some basic problems of reasoning about the arguments for AGI that saying I've invented something that's beyond definition and has got full generalities such that it isn't constrained by what I told it to do. I try to argue that this is just a direct equivalence in terms of argumentation structure of saying now that we've got magic, we don't need to be engineers anymore. So I think a little bit of that maybe is underpinning the foolish students, and I've seen this myself, who, as you say, they need a PID controller, they implement it with a deep neural network, and then they show that it's only slightly less stable than the 5-cent chip they could have bought.
It only requires 20 watts.
Exactly, yeah. And GPU.
One of the things that you definitely take like a big bat to a piñata is LLMs and whether or not they represent a form of AGI. And you used the word pastiche, and I really liked that as an explanation. Could you talk a little bit about that?
Sure. Pastiche is a great word, which I learned more about writing the book because I talked to an Italian colleague who was able to explain to me where the word comes from. It's a cooking term from Italian. The Italian word is pasticcio. And pasticcio means a meal where you just sort of mix up your favorite ingredients in a way that doesn't really have a kind of a grand scheme. It's just you put a bunch of stuff in there that you really like. And I've tried this out a number of times on Italian people now, and I say, what's the example of the first thing that comes to mind when I say pasticcio is like a lasagna. Lasagna is a pasticcio. It's not a sort of grand cuisine thing. It's just a whole bunch of stuff that's nice. It's got pasta, it's got meat, it's got cheese. Why would I not like all these things? So stirring stuff together just because the ingredients are things that you kind of like, but with no overall grand scheme, is a term that has been used in art history for a very long time. Back way before we had any kind of printing technologies or ways of reproducing art, people in places like Pompeii, if they're decorating the walls of the house, they didn't have wallpaper, but they liked to have nice pictures. So they would get some guy to come around and just put a bunch of pictures on the walls of their house of people feasting, or if it's a brothel, people having sex or whatever. And the guy that does this kind of work, he's just like your house painter. This is not a great artist who's going to be celebrated in history. He probably has been down to see the artists that the Pope pays, who are the really good ones, and he sort of has an idea of all those things, then he just puts some version of them on your walls. So that's where the term pastiche comes from in art history, is just sort of a jobbing piece of work where you kind of mix up nice ingredients that you've seen somewhere else, but you don't really claim to make it original. If you do a degree in art college or in music college or something, this is definitely what you're warned against. So nowadays, when you can just have a direct reproduction of the Mona Lisa if you want, you don't need someone to come and paint on your wall some poor imitation of the Mona Lisa. Nowadays, we want every artist to do something that's original. So pastiche is a term that is used by art tutors to tell their students, don't do that. Don't just imitate other people's stuff. You should have an original idea. And the definition, if you look back at the kind of textbooks on art theory that are trying to define exactly what it is that you don't want artists to do, there's this nice definition, actually for a couple of centuries ago, of saying the thing about a pastiche is that it's not a copy, but it's not original either. So I think that really gets to the nub of what it is that we find a little unsatisfying about LLMs. Is that, it's not a copy because it's not exactly like any other piece of text, but every time you read it, you think, this is really not very impressive. Everything here is just stuff I could have found on the internet. So I think that kind of makes clear what the limitations are. And in the book, I talk a little bit about the fact that this is one of the problems of morality that we're dealing with here. Because a lot of these engineering decisions, it's not that nobody's life is affected by this. People's lives are affected. So, of course, one of the things that we're really concerned about with LLMs is that there are people out there who are doing actual original artwork, but they're not being paid for it anymore because their original work got stirred into ChatGPT or something. And if you ask ChatGPT, please, can you write a novel kind of like this? Then as long as you don't use the novelist's name, which triggers the guardrails and says, oh, no, I'm not going to infringe anyone's copyright. But as long as you just sort of say, this is the kind of novel that I would like, without saying who it is that you're ripping off, then it'll very happily give you a whole bunch of stuff just like that person's work. And so that's why the Screenwriters Guild and so on are really upset that maybe studios will just kind of plagiarize their stuff at one remove by asking for things and not paying for them. So there's a whole sort of economics there of where the training data is coming from, why the architecture has been designed in a way that includes no traceability at all. And I even sort of argue maybe it has no traceability because that was just so convenient for the companies that invest in this. Like even if there had been a technical solution of how you could make traceability from the training data to the output, even if that solution was available, it's not in a company's interest to pay for it or even to ask the question. Like I wouldn't be at all surprised to learn that some researcher inside of Google or inside of OpenAI did discover a way of pretty effective traceability to original source documents and was told, we never want you to ever mention that again or do any work on it, because why would they want that?
That's called evidence.
Yeah, it's like neural networks are sort of like a plagiarism machine. They're custom designed to rip off intellectual property without traceability of the original sources.
And the guardrails are a lot like Star Wars guardrails.
Yeah.
They don't really exist.
I think that one of the things that bothers me, and you kind of touched on it with the larger issue of taking original work, which has been trained on, and then reproducing it, because the flip side is a lot of working musicians and artists are not producing the Mona Lisa and getting $10 million or whatever. They're making ad jingles for $50 or $200 couple times a week, or writing, making magazine covers or small pieces of artwork that they're doing on commission. And that's the sort of thing that LLMs are getting kind of okay at, to make just kind of a junky image or, a not very great song that's appropriate for an ad. And so the vast majority of working musicians and artists are, working class people doing small work, that's kind of being replaced, or the intent is from some companies to replace that kind of work. And I think that's going to be a major disadvantage for just society, because they're, those artists are paying the bills with scut work to work on actual, passion pieces and things like that probably won't be funded.
Totally true. And in the book, I really make a point that so much of what we call AI is in fact not a technology. It's a set of business models, and it's a consequence of certain economic policy decisions. And one of the sources that I draw on there is a great book by Rebecca Giblin and Cory Doctorow, Choke Point Capitalism, where they talk about the way that the digital realm is configuring so many different forms of media, so that creatives can only sell their products to one company, whether it's Spotify or whether it's Ticketmaster or whether it's Audible or whether it's YouTube. And once you get to that situation, that company can just drive the price down of what they pay, and they can drive it down to practically zero, because creatives are going to create. Even if you don't pay them, they will create.
Yeah.
And once you've got a monopsony, which is the opposite of a monopoly, where you don't have one seller but one buyer, and it drives prices down instead of driving prices up. And that has the effect that there's serious danger that all creative professions will have to turn into hobbies. That and unless you're Taylor Swift, that everybody else in the world maybe do the work for the love of it, or even worse than that, maybe they'll have to pay to publish their stuff.
Right.
Your royalties will be a thing of the past. And I sort of stop for my possible academic readers and say, you might think that sounds really crazy, but wait, this is actually exactly how professors have to work already. Like the most prestigious scientific journals, you literally have to pay to put your work into those journals. They don't pay you.
I liked the section where you talked about the effect of photography on painting.
Yeah.
Of course, it puts portrait painters out of work, because anyone could get the figurative images. And then it went from you had to have specialized equipment to us all having cameras in our pockets.
Some of them using AI. Sorry.
That aside. But, I mean, this reminds me, like, Socrates didn't think writing was a good idea because it would externalize thoughts when you should have them internal.
The jury's out on that one.
Yeah, maybe. When I'm being provocative, I think I tell people maybe with LLMs we've finally proven that Socrates was right after all, because we look at all these books and we think, wow, this is actually a lot of crapola. It's talking to real people. That's the interesting part. No, I think you're absolutely right that being modern humans for absolute centuries has about reinterpreting ourselves in the light of new technical changes, whether it's the printing press or whether it's desktop publishing, which put a whole lot of typographers and graphic designers and illustrators out of work, because a lot of everyday scut work, I think, as you said before, I could just do that myself. I didn't need to hire a typesetter to publish my church newsletter, because I could just do that on my desk. So, yeah, throughout my lifetime, there have always been whole professions where the people who were doing that job, it becomes mechanized, and within a couple of years they say, oh, what was my real job and what was I really wanting to do? So I used to worry about this a lot in my early career as an industrial automation engineer. So I would be going and putting automatic devices into a factory, and I would be chatting to the guys who worked in the factory so that I could learn more about how to make the system more usable and more efficient. And I would get worried and I'd say, but I'm sort of worried. Are you going to lose your job because I've put this machine here? And the response that I got more often than anything was say, this is a terrible job. Nobody should have to do this. So I will be super pleased. I think actually my employer respects me, so I think I'll probably get a job somewhere else in the factory. But even if I don't, to be honest, I would rather be doing something else. And I think we've seen that happening over hundreds of years, is that if people are exploited by their employers and they're driven into poverty, it's not the machine that's doing that. It's the decisions the employer is making about the economics of the company, or maybe it's decisions the government is making. So I think adjusting to automation is super interesting, and it's something that engineers can be really engaged with. And the downsides of that, we need to be clear that that downside is not a direct technical effect of a decision that engineers are making. That's an effect of the way that a company made use of that technology.
totally changing subjects.
Yeah.
What about LLMs in coding?
Yeah, exactly. Yeah.
Not changing subjects.
No, I was going to go on another rant about art, so this is good.
Certainly need to get back to the fact that there are many, many people writing books about AI at the moment, but not so many who are saying that the alternative to AI is better programming languages. So let's make the transition to that. This is a book for the general public, and some of what I do is just to give them a little bit better understanding of what programmers really do from day to day. Because I think that's helpful for everybody to understand more about where software comes from and why it's difficult to make software.
And why we don't spend all of our time actually writing code. As much as that's what we talk about and what it looks like, that's actually usually a much smaller part of our job than people expect.
Indeed, yeah. LLMs are great assistants for code writing. And I explained that, it's not so much different to predictive text. And in fact, the programming tools I use have had great options for autocomplete and refactoring. Sometimes the people selling them call that AI. So programmers are very good at making their own job more efficient. So we always take whatever is the latest advance and use them to make better IDEs and programming editors and so on. So that's nothing new. And of course, transformer-based large language models, they definitely help with, allowing you to quickly generate syntax from pseudocode and all that kind of stuff. So that's great. What I take care about in the book, though, is to say that this is not the same thing as the singularity coming into being because it has programmed itself to become kind of intelligent beyond what we can believe, what we can imagine, because that's an argument for magic, really. Yes, lots of programmers every day use Copilot and other LLM-based tools, but definitely it's not writing software by itself. So I try to strike a balance of acknowledging that these tools are super useful, but also that because they're not magic, they're not going to do some of the things that are claimed. There's a couple of interesting boundary conditions, though. So one of those is really trivial things. Make me a super simple computer game, or put some JavaScript in my web page to make an animated bouncing ball following the mouse. And it seems that you can do jobs like that pretty well with ChatGPT. Because they're so small and self-contained, and you don't need to know much about the context to make it work the way you've said. And practically speaking, of course, we know that ChatGPT its training data includes the whole of GitHub. So you can be pretty confident that somewhere on GitHub has made the program you want, and you've just got this kind of plagiarism avoidance thing here, that it's remixed their original code just enough that you can pretend that you generated that from scratch. And if you're lucky, it's not using a patented algorithm. Although I can tell you that the companies that sell these tools are pretty nervous that it might be. So that's one kind of that's an edge case where you can produce code straight out of the box, and it's a little bit more effective than just an even better autocomplete or an even better refactoring tool. And then the other thing that they can do super well is producing plagiarized answers to student programming assignments. So student programming assignments are the most context-free things you can imagine, because the poor professor grading them does not want to have to stop and think. A student programming assignment has got to be some really dull, out-of-the-box algorithm, because otherwise it's going to be too hard to mark. And of course, students are just relentless. They are always uploading their class exercises to GitHub and Stack Overflow and stuff. So it was already the case that any student who was determined not to learn how to code could find the answers online. Mm-hmm. And guess what? ChatGPT can do it just as well, because it's been trained with the same stuff. So for me, that doesn't tell us anything about whether AI will be able to program itself in the future, but it tells us quite a lot about the nature of learning programming.
The number of times I've used ChatGPT to try to write a script, write me a Python script to do something incredibly boring that I can't be bothered to do. I've had to spend a lot of time fixing it or correcting it or
figuring out what it's trying to do, because it's not what I told it to do.
And it requires a level of skill that is pretty high to interpret what it's saying and correct it.
And writing it would just be easier.
Well, sometimes that's true, definitely. So I think the message that, you can just use ChatGPT to program, I see that a lot. And people are like, just do this. And it still requires a high level of skill to take that and turn it into something that's actually correct. And you can miss things too, right? Like even if you have a high level of skill, bugs are hard to find sometimes, especially if you haven't written the code.
Undoubtedly, LLMs are pretty useful everyday programming tools. The statistics suggest that a lot of working programmers are using them all the time. And I think the Copilot integration into Visual Studio is pretty good. And I've got friends who do empirical studies of professional programmers, just finding out, they are genuinely useful in lots of ways. I don't cut a lot of code recently, but next time that I do a big project, I certainly expect that I'll get another productivity gain. But I think there is one serious danger here for people that are not professors building prototypes like me, but people who are actually producing safety-critical code or stuff that you really want to rely on. And the way that I explain this is to say, everybody knows what it's like to have a new programmer join your team who writes just really lame code. Like, it doesn't compile, it's formatted really badly, the identifier names are stupid.
Me in 1995.
Exactly. And we're used to having people like this on the team. Like, you sit down with them, you do code reviews, you beat it out of them, and after 10 years, they're sort of moderately competent programmer. And then sometimes they are super smart. They just make a lot of dumb mistakes, and that's okay too, because you can fix the dumb mistakes. So basically, it's all right if it looks bad, but it's really quite good. It's kind of all right if it looks bad and it is bad, because you can see it needs fixing. The worst, though, is you get programs sometimes that they produce code that looks quite plausible. It's beautifully formatted and stuff, but it's got some really terrible underlying logical flaw. Worst of all, if it's in some edge case that wasn't in the specification and the person never stopped to think about it properly. Well, that is exactly how LLMs code. It's the worst possible programmer in your team, because you don't want code that looks completely plausible but actually has a subtle bug that you had never thought about. So, in proper, large-scale software engineering, this is not the kind of coder you want on your team.
We did an informal poll of our Slack group on who uses GitHub Copilot. And I was kind of surprised at how few people loved it. A lot of people had tried it, and some people used it intermittently or used it until it became irritating and then stopped using it.
There were several people who used it regularly, but they knew its limitations too. Yeah.
Yeah. I from my knowledge of the literature and empirical studies of software engineers, your informal poll definitely aligns with what researchers are finding as well. Yeah, that certainly is the case.
Well, and we're pretty niche. I mean, embedded isn't standard.
It's probably not well trained into ChatGPT.
It's not as well trained into ChatGPT.
Give me an STM32, whatever, HAL. Yeah. I mean, it's out there. There is stuff in there, but it's worse.
Yeah, interesting. I mean, a lot of my research colleagues in the compiler groups and so on, there's really interesting intermediate languages. The last assembler that I did a lot of work in was 68,000. So we're talking more than 30 years ago. I think people are certainly making virtual machine languages and intermediate languages that are designed as LLM targets. So I think we'll get more interesting stuff.
What do you mean by that?
So what I mean is, at the moment, as you say, the kind of languages that embedded software engineers work with, there is not a lot of examples of those in the training data for your mainstream commercial large language models. But if you designed a very low level language, so like, maybe LLVM or something like this, and constructed its syntax in a way that is going to get efficient weight distributions in a typical transformer architecture. At the moment, I don't think there's been a lot of customization
Interesting.
I think they've just been sort of relying on the fact that it looks kind of like text, but I'm sure they've done custom tokenizations, but I don't think that you see PL semantics. There used to be guys actually. I did know people who worked on use of attention architectures for program language synthesis, but that was in the days before BERT and the huge swing of enthusiasm towards very, very large natural language training.
So you're saying that we could design programming languages that LLMs would consume better?
Totally.
And therefore,
totally.
oh my God. Okay.
Yeah, I think so. Yeah, probably. I mean, this is, I've got colleagues here in the computer science department who are the real experts. But if I was chatting to them and just brainstorming what we might do, I guess to get a big enough training set, LLVM, we've got good compilers to and from, also, definitely to C and to various assemblers and so on. So that means we could actually synthesize quite a big training set where we've got cross-modal data from specifications and comments. Yeah, so that would probably be, I imagine people are attempting this. It seems like that would be a good approach.
When I say ours is niche, it isn't necessarily about it being C. It's more about trying to deal with one of 1,000 different microprocessors interfacing to one of 100,000 different peripherals and doing it with or without DMA at this certain speed and blah, blah, blah. And I mean, that's what makes the job challenging and interesting and hard and sometimes impossible. And
slow to develop.
Yeah.
So that used to be my job. Assembly programming and dealing with all those nasty little issues. And I not only did I work at that level, but I used to design the CPU boards that ran the code that I was installing in factories. So right down to the hardware is a thing I used to do. But to be honest, my current job is a lot easier. So, so all respect to your listeners on Embedded, because I totally understand that is real work. One thing that I do like to do when I'm talking to proper programming language designers and compiler builders and so on, is to have them think a little bit more about whether you can give some power of programming to people who are not actually engineers and who are not, didn't take computer science degrees or engineering classes.
End user programming?
Exactly. This is the field of end user programming. So it's giving people the ability to just write enough code to be able to automate the drudge work from their own lives. And the absolute classic example of this is the spreadsheet, which is a programming language. It's a very specialized domain-specific programming language, and the source code is kind of weird because it's all hidden inside and you can only see it one line at a time. But despite all of that, it's super useful for people that would otherwise have to spend a lot of time sitting down with a calculator typing in numbers. So giving that kind of spreadsheet power, but for people who aren't accountants. And we're getting a lot of a variety of things that are probably Turing complete in some kind of way. It can definitely automate stuff that would otherwise be real drudgery. A lot of these are the things that are called low-code, no-code languages. Whether it's wiring together data flow components or specifying simple transformation rules. You can give people a lot of computational power without necessarily telling them that they're programming. And that's why the title of the book is Moral Codes. So codes is a reference not just to like legal codes and things, but also to the power of giving people the ability to program. So codes can look like anything. They can even look like graphical user interfaces. And I realized about halfway through writing the book that the title Moral Codes also made a nice little acronym. So the acronym or backronym is More Open Representations Accessible to Learning with Control Over Digital Expression. And that's kind of what we would all want our programming languages to be, and also what we would like our UIs to be. We would like them to be representations that show us what the system is doing, and we would like that to be open, and we'd like it to be learnable. And quite often, we would like it to be, for many times, we want to be creative or we want to be exploratory, we want to express ourselves. So quite a lot of the book actually talks about just experiences of being an engineer that are sort of things that are fundamental to being human. Expressing yourself and having control over what goes on around you, not having to spend too much of your life in drudgery and repetitive stuff that could easily have been automated.
I liked that section of the book. It reminded me a lot of expert user interfaces versus novice user interfaces. And expert user interfaces, you think about Photoshop with all of the buttons and windows and toolbars and
shortcuts.
You can do everything you want, and you can do half of it from the key commands if you're willing to learn those. But as a novice, walking up to Photoshop, it just makes me want to turn around and walk away.
Yeah, it's easy to confuse the needs of what kind of usability you need for someone who's an expert that might be using the system every day, and what kind of usability you need for a person who's only going to interact with this thing once a year, like doing my tax return. So, maybe when I was younger, I could remember things that long. But I have to say nowadays, I come up to do my tax return and every year it's like, oh, this is the first time I've ever seen this. So I really want that to have the most basic tutorials and things. I only do it once a year, so I don't mind as long as things are clearly explained. I don't mind if the buttons are very big with pictures, because I don't want this to be any more painful than I like it to be. But my accountant, well, actually, I don't make enough money to have an accountant. But if I have an accountant, they would be really pissed off if they had to use an accounting software that has got great big buttons and explanations of everything to do, because they use this thing every day. So, they want to have all those power facilities right at their fingertips. So, yeah, there's a difference between a system like Photoshop and a basic drawing application. But I think we see gradual evolution in many parts of computer user interfaces, where things that at one time were considered to be accessible only to programmers turn out to be kind of useful for other people. So the very first paint programs didn't have any notion of putting layers of an image over other layers. So if you put another paint stroke, it would destroy all the stuff that you had already done. Whereas a good user of Photoshop knows you get your base layer, and maybe you put your photograph there, and then you put your masks over the top of that, and then if you've got some text, you put that in another floating layer. And that sort of makes it easier to rearrange things. It makes them easier to visualize what you've done. You can show and hide them. You get all sorts of sophisticated capabilities from this pretty simple abstraction. Like, there's just one thing I want to add here, is the idea that there are layers to your image. So I think that's an example of the kind of advance that I look for in end-user programming systems, is some simple abstraction that has turned out to be super useful and even essential to professionals. But it's not so hard to learn. And if you just figured out a way to put it into the UI in a way that is intuitive and understandable, so the first time you use it, you can see how it works. You don't need to go on a training course and say, oh, now that I see what I can do with this, okay, I can achieve a bunch more stuff. So I think a lot of media authoring tools do have those sort of abstractions built into them. And to some extent, a lot of the stuff that you do in graphical user interfaces, there's always more potential to think a little harder about what those mean in terms of the semantics of the diagram, what the syntax is, just thinking back to the fact, oh, yes, that's a programming language. But what we really want to avoid is taking that away from us. Because quite often the companies we buy software from are not very interested in us controlling the experience better. What they would really like is that they have more opportunity to surveil us and sell our data to their customers. And my friend Jeff Cox said, basically you've got a choice, program or be programmed. And I think that is, that is really where we are here.
That's right up there with if you're not paying, you are the product.
Absolutely, absolutely. Program or be programmed. Asking whether our user interfaces are things that show us things about the system state and allow us to modify it with direct instructions, or whether the system state is hidden and we're sort of allowed to provide training data, but where it's very difficult to give an unambiguous instruction of you definitely want the system to behave differently. In my classes where I teach user interface design, and I ask my students to think about just how good is a smart speaker, like Amazon's Alexa or something. Like, would you like to do your programming in future by just talking to Alexa and say, oh, that would be brilliant?
No.
Well, exactly. You talk them through so this would mean that the source code is invisible, and you have a one shot, like you just have to speak it right the first time and you can't go back and edit it. How good a programming language is that? It's like, oh yeah. And, there are many, many people who suggest that the graphical user interface will go away, that we won't have any representations, we won't have any diagrams, we won't have any words. We'll just speak to the artificial general intelligence. And there's even a phrase for this. They call it, there's this research community calls it natural user interfaces. And supposedly this is going to be the successor to the graphical user interface, the natural interface where you just speak and you never have to look at anything. Well, that is classic program or be programmed. That would be heaven for the surveillance capitalism companies, because they can sell you whatever they want and you've got no remaining control at all.
Meanwhile, we've got typewriters attached to every computer still, and that doesn't seem to be in any danger of changing. Nobody's beaten that in terms of input. I worked. I had the privilege to work with David Mackay, who was one of the geniuses of the 21st century. Really, among his many incredible things was to create the first machine learning driven predictive text interface, a thing called Dasher, which is still available online in some places. And he proposed it as an alternative to the keyboard. It was super impressive, and it could predict text words ahead at a time when we still had the T9 system for sort of spelling out your words on your feature phone handset. So I worked on Dasher with him about 25 years ago, and it was pretty clear at that point that language models would be able to produce pretty long streams of text that looked just like the kind of text that I would have wanted to write anyway. It turned out, though, that although the Dasher interface was very information efficient, it was like playing a fast video game, because you could type text very, very fast as long as you watched what was coming out of it and controlled the mouse to steer towards the sentences you were wanting to write. As it turned out, it was far more effective to integrate that with the keyboard. And actually, a researcher who worked with David and then with me and is now a professor in Cambridge, his PhD dissertation was to invent the thing that we now know of as the swipe keyboard. So what he did was to integrate Bayesian language models with something that looked like a keyboard, which meant that if you didn't want to go too fast, instead of like drawing those fancy shapes, which is pretty fast if you do it well, you could just go back to pressing the keys one at a time. So I think that's we've trained ourselves to be keyboard users, not just QWERTY keyboards, but even musicians get to use the piano keyboard with all the black and white keys, which is pretty fast. Once you know how to play it, you can get those chords out very quickly. But it's also very constraining, because if you wanted to play a note between the keys, you can't do that on a piano. Yeah, so we've got some trade-offs there. The keyboard is not fully optimal, but a lot of it has been kind of optimized into muscle memory so that we may not see it disappearing very soon. Certainly, it's pretty annoying to interact with people who can only type as fast as they speak. Right.
Most practiced keyboard users can type interesting stuff quite a bit faster than they can speak.
I can type faster than I can think sometimes. Just check my emails.
Which is why waiting before sending is very important.
You mentioned predictive text and its helpfulness to you, even writing in your own style. How much AI, whatever that is, did you use in writing the book? Did you experiment with any of that?
Yeah, I really play some games with my readers. There are pieces where I ask them to guess how I wrote a particular sentence. I wrote the whole of the manuscript of the book actually originally before the launch of ChatGPT. So I'm a bit relieved that I did quite a good job of anticipating what was going to happen next. So between the original delivery of the manuscript and then delivering the final revisions the following summer, ChatGPT was released in that gap, and I had to go back to the book and say, how much of this do I need to change now that everybody in the world knows what this stuff is? Because previously I'd had to put a lot of effort into explaining what a large language model is and why it was going to be interesting in the future. So so ChatGPT wasn't there when I wrote the bulk of it, but it reported some experiments that I did with GPT-2 and other earlier models. I think something that I reflect on a bit is the role of craft and sort of embodied practice, which I guess I've alluded to a little bit when we were discussing keyboards just now. And I think a lot of people who do a lot of coding, that stuff comes through your fingers. And you don't necessarily, just like you said, Alicia, you don't necessarily think about, it comes out before you've even thought about it. Definitely this happens when I play my musical instrument. I've been playing in orchestras for 40 years, and I definitely cannot describe to you the notes that I'm playing. They go off the page, into my eyes and into my fingers. There's like no brain bypasses. So I think that What was interesting to me as I was writing the book is those craft elements. And I was definitely reflecting on the tools that I was using to write the book and how they related to what I was saying. So I used a couple of predictive text technologies routinely. So one is that I use a MacBook Pro with a little sort of smart the display bar above the keyboard that in a lot of applications on the Macintosh, it'll come out with a choice of words, which occasionally I find it faster to grab that from the top of the keyboard rather than keeping typing. What I did far more of was that I wrote quite a lot of the final draft of the book in Google Docs. And that was complete whole sentences. And then I had to say to myself, well, I could complete the sentence that way. Is that what I want to do? I mean, these were experiences that were sort of novel experiences a year ago. Nowadays, this is everybody's everyday life, isn't it? So you guys, I'm sure, are thinking about this all the time. But in a sense, it was what was already happening with our mobile phones, because your predictive text keyboard is doing the notorious autocorrect and saying, yeah, well, you typed some stuff, but I think you really want this word.
Right.
Like, no, I don't want that word. So it's interesting being inside this probabilistic universe where, every engineer using these things knows exactly why it's doing the predictions it wants, is because it's predicting the lowest entropy thing that you might do next, which is also precisely the least original thing that you might do next.
It will never spell my name right. Or if it does, it will someday spell my name Elysia, spelled like electricity, because that's the only way it's ever spelled correctly.
You are definitely on the wrong side of history here.
Yeah.
Yeah, my daughter has got a name that is the most famous female Blackwell in the world, which I sort of thought was, an honor to the great pioneering American doctor, Elizabeth Blackwell. But it's not great for my daughter when people want to Google her name, but it does mean that predictive text keyboards know exactly how to spell it. It's just a bit sad that she decided she wants to be called Liz, because now it's like, oh, no, that's too much entropy for me. You're going to have the same name as the famous doctor.
Oh, one of the things you mentioned in your book is about self-efficacy, and Chris came across this article about how AI suggestions for radiology causes humans to perform worse when it is supposed to augment them.
Yeah, really worrying. And this is definitely something that I discuss in my graduate classes on human-centered AI, because I think this is really dangerous, and we definitely need to think about designing for this when we're thinking about the system boundary for our design project, drawing the boundary that includes the users and the organization as part of what the engineer needs to be concerned with, which is, of course, what all good engineers have always done. So once you think about how this AI system is going to be used in practice, and you think what I'm interested in is the joint performance of the human expert who's working with the AI, and then studying what happens when you make different changes to the impedance of the channel that they're communicating with. There's a PhD student of mine did a fascinating piece of work exploring something that no one had ever looked at before, which is the question of the timing between when you say something to the computer and when it speaks back to you. So in conversation, this is like a really important part of human conversation. Conversation is very musical, and music researchers have shown the ways that turn-taking between people who are having a nice conversation, they settle into a kind of rhythm. They say sentence, they say, the way that you just did. Conversation is a kind of music. So my student, who was advised by the director of the Center for Music and Science in this work, she said, I wonder if any of that is going to happen when you interact with computers. So she created a simple conversational AI system in which a human expert is having to respond to judgments by an AI that may or may not be right, just as in the radiology example that you've sent. And she just made subtle manipulations to the speed with which the response would come back. So in some of the conditions, it would mimic what humans do. So if you delayed a bit, it would delay a bit before it responded, which is very different to the usual approach to user interface engineering, where the goal is usually just make it respond as fast as possible. There's no speed that is too fast, just as fast as possible. But of course, in human conversation, that's not true. you don't want me to respond as fast as possible. In fact, we call that jumping down your throat if you respond too quickly in a conversation. So she made different versions of her collaborative human expert, AI expert system and just changed the conversation speed. Well, she found something really disturbing, which is that if the computer responded in a more human-like way, so that you really felt like you were having a nice back and forth, people were more likely to agree with incorrect judgments by the AI.
More trustworthy.
Exactly. So as it became more human-like, they said, oh, yeah, that must be right. And they accepted incorrect recommendations from the AI more often.
Well, sure, because the computer thought about it.
Yeah, that's clever. You know, we've published that work, and I don't think any of the peer reviewers ever suggested your explanation. But yeah, now I'm going to have to mention this when I tell students. You may be right about that.
Well, that's funny because it's like when I'm playing chess, and like if I've got the level turned way up and the computer's sitting there spinning, I know I'm in deep, deep trouble, right? Right? Because it's thinking hard. It's like, oh no, it's looking 600 moves ahead. I'm doomed. It's a similar thing, right?
And I don't know this for sure, but I know a lot of people suspect that when you interact with the large language models, that the response speed is slower than when the tokens are actually coming out of the server, and that they do that to make it more emulating human. I don't know if that's true or not, but certainly a lot of people believe it is.
Feels true.
It does.
Probably is. Who knows?
Yeah. So, but I think coming back to the question, having designing systems in a way that undermines human experts, or even worse, sort of subconsciously encourages them to make incorrect judgments by not recognizing the limits of the algorithm you're using. I think that's super dangerous. And I fear that it's going to be a big problem for us, including, of course, with people who routinely just use ChatGPT and don't think too hard about what it's saying back to them.
Why are we trying to create human intelligences within AGI instead of something more interesting like octopus intelligence?
Because we don't understand octopus intelligence. or human, but we really don't understand octopus.
But at least we know we don't understand it.
Yeah, well, that is definitely one of the problems with the phrase AGI, is that you're talking about some kind of intelligence that like supersedes every species on Earth and like transcends the notion of the body. So yeah, we're already in deep philosophical water there. So you could say, in a sense, that that engineers of algorithmic systems are designing new intelligences every day. We're just not very grandiose about it. And AI researchers have always loved to talk about the thermostat, because a thermostat it acts on the world. It's got sensors. It's got internal state. It meets all the definitions of classically what an AI is supposed to be. It's just that once we get used to it, we prefer not to call it AI because we've moved on to more interesting ideas. So, yeah, octopus intelligence, not so sure that I need an octopus in my house, but thermostat intelligence, yeah, more useful.
One of the things I did like about your book was discussing what intelligence is and how that word really is more of a cultural artifact than any measurable thing.
And this is based on work by my colleague, the philosopher Stephen Cave, who just went back to look at how we started using the word intelligence in the way that is very familiar to us in the 21st century. And he went back to projects that were trying to scientifically measure what made some people better than other people. It used to be called anthropometrics. And through the 18th century, the 19th century, it became increasingly popular because there were people feeling guilty about slavery. There were people feeling guilty about colonialism and racism.
Not the way to solve that.
Well, it was the scientific age. And they sort of said, well, it's obvious that these people are inferior to us. It's just that we never tested that scientifically. So, because of the tragedies of Nazi Germany, this was the philosophy of Nazi Germany, and it used to be the science of eugenics. There was a journal of eugenics. It was a respectable scientific discipline, and it was the discipline of improving the human race by measuring which people are superior.
Using phrenology.
Well, I'm looking at a phrenology head right now because I have one in my office just to remind people how stupid this is. But all of the stuff about intelligence testing was part of that project. Intelligence testing was fundamentally a racist project. And Stephen, in his history of the use of the word, shows this super convincingly, that the word intelligence as a thing that you could measure and was considered to be something scientific rather than just a thing that philosophers talked about was totally associated with eugenics, with anthropometrics, and motivated by racism. So I actually say, if intelligence was only ever about racism, then does that mean that artificial intelligence is artificial racism? And there are people who definitely claim that. Ruha Benjamin at Harvard writes amazing books, just looking at the fundamentally racist design of a lot of stuff that is around us, and we don't think to ask about. But I don't see you guys' faces. I'm guessing you may be white. Certainly, your surname is white. So there we go. But I'm an old white guy, and I have a pretty easy life. And it gives me the illusion, because I'm an old white professor at Cambridge, that everything that comes out of my mouth must be, it doesn't matter where those words go. Obviously, they are super intelligent. You can put them in a book. You can put them in a machine. It's nothing to do with my body. They would be intelligent from anybody. But I know that I've got colleagues who are black, and I've got colleagues who are younger, and I work a lot with computer scientists on the African continent. And those people, they can say exactly the same words I do, and it doesn't sound intelligent to other people, because I have got the luxury of pretending that my words would be received as the same no matter what body they came out of. But a person who's got a black body or who lives in the wrong place, they know very well that that's not true. Intelligence is not a disembodied thing. Intelligence is actually pretty much bodied, and it's only the people who've got the right kind of bodies that can pretend otherwise.
Okay, so
octopus bodies.
To wrap this up, and at the risk of asking you to be my therapist, I have a great deal of despair about all of the things happening in technology, but particularly where LLMs are going, and not the technology necessarily, but the way they are being used, abused, and marketed. I have a lot of friends who occasionally, they know I'm a musician, and will occasionally send me, hey, there's this new website that you can generate a song, and then they generate a song and send it to me, and they say, what do you think of all of this?
And then he's infuriated for the rest of the day.
I try not to respond with the Miyazaki quote, I find this to be an insult to life itself. How should I be engaging as an experienced technologist and engineer with this stuff instead of disengaging and going and sitting and just playing drums and not getting paid anymore?
Cool. Well, I'm so pleased to hear that you're a drummer, because that's just what my band needs at the moment. This is not a serious I'm solving the problems of the world, but this is here's a fun game that I'm playing because I'm a professor in Cambridge and I can. With a few good friends who are also a little bit suspicious about traditional definitions of knowledge as being sort of inside old white men's bodies. Mm-hmm. And so they talk about feminist theorists like Donna Haraway or Karen Barad. Those feminists were already pretty suspicious about all the text in the world that is written by old white guys, and that women sort of have to go along with believing it. And we're at an interesting point now where text has eaten itself. Like we've created these things which literally produce bullshit, as I said in a blog entry last year, and I've now got some hard scientific evidence for it that I'll be publishing soon. So these things, until pretty recently, universities in this country around the world sort of thought that as long as professors were producing text, they were doing a good thing for the world. But it seems kind of clear now that there's sort of too much text, and that producing more of it is not necessarily good, because we can now just do that with LLMs. So if there's somebody out there that needs bullshit, well, that's good. They can just sit and chat to an LLM, and maybe I should do better things with my life. So with my feminist theorist friends, I said, what would the post-text academy look like? Because we're always going to have young people, and we're always going to have universities, learning is part of being human. But if it's not about teaching them to write essays, and if we're not being evaluated on our research outputs and academic papers, what will we do with our time? And so we've been trying to invent a kind of knowledge which is as far away from text and as far away from symbolization as we could possibly make it. So we formed a doom metal band. We play so loud that your body shakes, and no one's going to turn ChatGPT up that loud. We use a lot of distortion pedals, and my friend, the singer, who's a professor of creativity, she trained in Mongolia in overtone singing. So the noises she makes are not regular notes. You can't really write them down as a piece of music. We're having a lot of fun. We've played our first gig, and it was too popular, so we've had to say we're only going to play underground from now on because we don't want to do this in front of a big audience. But definitely, this is seriously challenging. What is the value of an LLM? How much time are we prepared to spend having a conversation with a thing that doesn't have a body?
I'm fine with not having a body.
You
I
reckon?
just want it to have more than a pastiche of random stochastic poetry.
Yeah, I feel like we've gone back to which science fiction books we liked the best. Yeah,
Yes.
Imagining having a different body is an interesting thing, but coming to terms with the fact that you're in a body, yeah, I guess I'm a good many years older than you, Alicia. I'm sort of getting towards the point in my life where this body's going to give out sometime, and I can either be Elon Musk and say, when I'm immortal, I'm going to go and live on Mars, or else you can say, actually, this is what it means to be human. To be human means to be born. It means to die, and it means to be youthful, to be old, to do all those other things. So quite a lot of the book actually says, just think about what it means to be human, and is AI helping you with that? Or maybe moral codes, computers that will do what you want and help you achieve what you want. Maybe that's what being human is about.
Alan, thank you so much for this wide-ranging conversation. It seems a little redundant, but it's tradition. Do you have any thoughts you'd like to leave us with?
Yeah, I think the reason why we need less AI and better programming languages is that having control over the digital realm allows us to become more properly human. And a lot of the things being sold to us by AI make us less human and give us worse lives.
Our guest has been Alan Blackwell, author of Moral Codes, Designing Alternatives to AI, and Professor of Interdisciplinary Design in the Cambridge University Department of Computer Science and Technology.
Thanks, Alan. This was really great.
Thank you very much. It's been a pleasure.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for their questions and answers to my polls. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM where there will be show notes. And now a quote to leave you with from the very beginning of Moral Codes. There are two ways to win the Turing test. The hard way is to build computers that are more and more intelligent until we can't tell them apart from humans. The easy way is to make humans more and more stupid until we can't tell them apart from computers. The purpose of this book is to help us avoid that second path.